Patterns by the Gang of Four is very famous. And also outside of the field of developing, you have patterns. So if I want to knit a Celtic pillow, I wouldn't know where to start. So first I Google, and then I get this kind of stuff. I'm not sure what it is. It looks like brainfuck code, but probably it tells me how to knit a pillow. So what is a pattern? A pattern is a reusable solution for common occurring problems that you can apply. It's not some boilerplate piece of code that you just copy paste and you're done with it. You apply it to your own context, but you try to reuse it. You try to see when does it make sense, when does it make sense. And in the pattern description, the pattern language, we mention when is the good problem to apply this pattern, when you shouldn't do it, and if you're applying it, what are the considerations, and of course, some code examples. Microsoft guys with their Azure cloud, they also release all kinds of patterns. So in all kinds of software engineering fields, you have this pattern system. So probably the next version of this slide will have the blockchain pattern in here as well. So when looking at the patterns, we discovered three areas. We have data patterns, transaction and value patterns, and we have action and control patterns. Probably there are much more different categories, but these are the three distinctions that we came up with. And I'm going to mention 6 examples from this set. Actually, this morning, we've seen the fan-in and fan-out pattern from the Block Apps demo. We have seen the escrow example earlier. So already during this day, you have witnessed a couple patterns without even realizing it. So for each of these patterns, we'll mention, well, of course, the name of it, a definition of the problem. So when can you apply this pattern? And then if you're going to apply it, what kind of context, what kind of considerations, what kind of constraints are there to be sure of? Followed by an actual solution of this pattern and a couple examples out of all the code that is publicly available on GitHub already. And you see these patterns are quite often related to each other. So if you use one pattern, you might as well consider another pattern or even use them in combination of each other. So first of all, the data patterns, two examples. The first one is the name registry. It's so you need this if you are looking for a human readable name for an Ethereum address, and you might need this human readable name because you want to display it in your user interface. Maybe you have a wallet application and you want to show the person that you're transferring something to, or you have a game and you want to show the nickname of the person that was just winning your contest, or because your DApp consists of a cluster of contracts that are related with each other, you want to make a reference from one contract to the other, but this relationship isn't known up front. So you want to refer to the other contract by name instead of hard coding the address in your contract. And of course, that has the advantage that if you update the name registry, you can also update the code of your code construct. And you can even apply hierarchical patterns here, where you get some kind of subdomain registry. So you can register, you can appoint a registry for a domain, and then for every household within an area, there would be another reference to another name registry for the individual people living there. Of course, there's some issues with this. You have the traditional kind of problems that you're also seeing in the DNS name registry. So you have this name squatting potential. What happens if you lose your key? Is this name going to be lost and we're going to expire it? Maybe you can outbid somebody else. So there's all these complex things to think of as well. So a solution here is to create a contract, a registry, and this could either be a global one that you use in all your Ethereum applications, or it could be one specific for your context or for your application. And it has a reference from a name to an address. It's just a big hash map where it just looks in the contract storage for the given name, what is the address that is associated with it, and then it returns the address. And you can extend this by giving a reverse lookup. So you can query it for an address, and then you can see what is the name that belongs to this address. And a good example here is the name reg contract that is actually implemented by Gavin, I think. It's in the DApp bin GitHub project in the Ethereum repository. And here you have the name register implementation. So you can take a look at this and see how Gavin does it. So the second data pattern is this data feed. Smart contracts, they cannot reach out to the real world. You cannot make a HTTP call and see what a website returns as a value. You cannot directly connect a camera to it, so you can make a picture. So you need to actually feed the data to your contracts to get some kind of value out of it. So what if you're making an application that needs to know the weather for a certain area, or it needs to know an exchange rate, so you can exchange your Ether for Bitcoin or vice versa. And yeah, there's this limitation of the Ethereum virtual machine, where because it's deterministic, you cannot look outside and fetch data into the blockchain by itself. So what you need to do, you actually need to feed this data into Ethereum onto the blockchain, and then once it is there, every other application on the Ethereum blockchain can actually use it and reuse it and use it in fashions that you really didn't think of yourself before. So typically you'll need an automated process, some kind of daemon that frequently publishes updates to this data feed. So maybe once every day what the weather was or what the exchange rate was, or more frequent or less frequent depending on your usage. And of course you can publish this as a free service, but you can also ask for a fee if people are getting the data out of this data feed. So of course there's some cost associating with setting up such a process that keeps updating and keeps pushing data to the Ethereum contracts. At least you need to pay the gas and also some kind of hosting fee. So you could actually charge every contract that is using this, and that could be a viable revenue model for a data feed. Yeah, I've given you these examples already. And a much more advanced example is the BTC relay contracts, where it's actually storing blocks and transactions from the Bitcoin onto Ethereum. So then you can use this on the Ethereum blockchain as well. And as an example here, we have the price feed example from Nick Dodson. I think he's also here or might be presenting later this week. So here they're pushing fiat currency prices on the blockchain, and then you can use that for some kind of set up some kind of trade, set up some kind of escrow without having to rely on the exchange rate of Ether itself. So, looking at these transaction and value related patterns, two examples. The asset token, we have seen that in Peter's presentation. So you need to have some kind of representation from either a virtual or a physical asset on the blockchain, so you can, for crowdfunding purposes, so you can sell it, or maybe so you can lease your car, or you can trade it with somebody else, or you can track it for auditing purposes. And typically these assets are equal in kind, so you can enumerate them and you can have multiple of them. And if you use a standard interface, and there's the meta currency API description on the Ethereum wiki, if you use the same kind of interface for this, then you can use all kinds of different wallets and exchanges to track your subcurrency, to track your assets, without the wallet itself having to specifically support you. So what you do, you create a contract, and basically you track per account how much of these assets they have in the contract storage. And then you set up maybe at least two functions, one to transfer these assets from one account to the other account, and one to return the balance of one of these account holders in there. And if you have this, you can use this to create a crowdfunding tokens, set up IOU constructions, track fiat currencies, so US dollars, euros, whatever, or even as Digix is doing, keep track of gold certificates on the blockchain. And here, as an example, is from Slockit, their crowdfunding contracts, where they're also using this pattern. So they're doing some kind of crowdfunding. Probably we'll hear more about this later on. But you can transfer these tokens to somebody else, and you can also see what your balance is. Another one of these value and transaction-related patterns is the exchange or market. So you have one of these asset tokens, so that's actually from the previous example, and you want to sell it, buy it, exchange it for something else. So you can set up an exchange on the blockchain itself. You don't need any kind of central website that will do this exchange for you and then lose your money and run away with it, but you can do all of this on the blockchain. And typically, both the assets for a one-on-one exchange will be one of these assets on the blockchain, or one of the two could be just the Ether currency itself. But that, I guess, that's less common. And then, of course, the trick is, how are you going to do this settlement if you have a huge ledger? Maybe it's very good to have the user indicate which is the winning pair and have it matched that way, or you need some kind of external trigger that will be called to do the matching and the settlement payouts. But that's potentially expensive. So what you need to do, you need to have a contract, you need to keep track of the bids, all the buy orders, keep track of all the asks, all the sell orders, and have some kind of matching mechanism. And once a bid and ask is matched, you swap the assets from both account holders to the other one. An example of this is Vitalik's Cyberdyne market. It's written in Serpent instead of Solidity, so it's a good homework exercise to try to convert that from Serpent to Solidity. And another example is the Etherics Exchange. So here an example from Cyberdyne. You see there's a buy function, there's a sell function, but you can use this market, this exchange, to exchange all kinds of assets that have the same interface without having to upfront implement support for this in your contracts. So the third and final group that we have seen are these action-related patterns. Event log, so it's a feature of the EVM itself. You can emit events and they will be persisted on the blockchain, and you can use them to track state or to track when some kind of action happens and have the outside respond to it. There's a limitation though with the EVM. From one contract you cannot inspect the event log of itself or of another contract. So you can only use this data from the outside, but this makes it ideal for user interface purposes, or if you have some kind of watchdog process that is looking at these event logs and act upon them. So yeah, it's just a single line of Solidity code to emit an event if an action happens, and then you have a listening process or a watching process in your user interface that will update its state accordingly. So examples of this: if a buy order took place, maybe you want to update your crowdfunding website. If you just leased your car key to somebody else, you need to change the code, the public key on the log system. If an account is registered, maybe some other event takes place. So a good example here is the Y Fund, again from Nick Dodson, the Y Fund crowdfunding contracts. So yes, these events that are emitted when a new campaign is created, when a contribution is made, when a payout happens, and even when a refund happens. Maybe he doesn't even use these kind of events himself, but by just sharing them, you allow others to consume them and create all kinds of user interface and interactions with them that you didn't think of yourself. So yeah, there's a bit of an issue with Ethereum. There's no alarm opcode. You cannot trigger some kind of future event to happen automatically. So every action in a contract needs to be triggered by a transaction that is eventually being sent from a user. So what if something needs to happen in the future? How are you going to to make sure that this happens. An example for this are if you need some kind of, I don't know, expiration of your lottery tickets, doing frequent dividend payouts, other kinds of cleanups. How are you going to make sure that this will happen? So the solution here is to reward the caller for actually triggering this mechanism. So you create a function. Anybody can trigger this, but once they do this, they get rewarded for doing so. And that way you hope, of course you cannot guarantee that somebody will do it, but they have a strong economic incentive for triggering this method and making sure that it will be called. So an example here from Gavin's casino contract is this recycle method, which anybody can trigger, and if there's some kind of expiration event, the person that was triggering this gets rewarded with 0.5% of the funds. So makes sense there. So combining these things together, you can come up with all kinds of use cases. So say you have a betting website where you want to allow your users to bet on soccer scores. You would use a name registry to keep track of the different usernames, so you can have a top scoring list, a Hall of Fame on your site or on your DApp. You need some kind of data feed to know which soccer events happened and what scoring was there. Event log. So if somebody takes a bet or if you won, you want to update again your website or your DApp accordingly. So you use event log to get the output from that. So already you see with such a system, you're combining multiple of these patterns together. Again, for market, if you have some kind of manufacturing site and when you do some kind of internal research optimization, you can try to centralize this, but you can also think about, can we do this on the blockchain using asset token to indicate resources, having an exchange contract where people can bid and ask for resources, and then of course, having some kind of incentivized trigger for making sure that frequent updates, such as market settlements, happen. And another example is if you want to have your DApp interact with real hardware. So in this case, it's a smart meter in my utility closet that I connect with my Ethereum Raspberry Pi. I get data out of it. But how do I know that this device belongs to me? So I need some kind of notary data pattern that makes this association. I have this data feed, so for every energy consumption update, a contract is updated with my data usage, and if I want to display this in my DApp, I need to emit event logs using the event log pattern. So what's next for you guys? Take a look at existing code in GitHub, existing contracts, study them, and see what kind of common patterns do you see are used and can be reused for yourself. And also, we're trying as a community effort to get this Stack Overflow, Stack Exchange site set up for Ethereum. So if you go to Area 51 on the Stack Exchange, please vote for it. As of this morning, I think we were at almost 70%, so a couple more votes, and we have a community site for all kinds of Q&A, all kinds of discussions around best practices, about patterns, sharing code, sharing knowledge with each other, and this would be a great place to exchange Ethereum or DApp patterns as well. Thank you, guys.